Following the established pattern, we talked about osteology and kinematics and arthrology and stability, and now we're going to go on to talk about the muscles of the hand. So the innervation to the hand is pretty similar to the innervation to the wrist that we talked about. The radial, median, and ulnar nerves innervate the skins, joints, and muscles of the hand. Normal sensory innervation is essential for protection of the hand against mechanical and thermal injury. So if you don't have normal sensory innervation, you will not take your hand out of the fire when it gets hot. So persons with peripheral neuropathy are more vulnerable to injury because they can't feel when their hand's in the fire. So just like in the wrist and forearm, the posterior or dorsal side of the hand is mostly innervated by the radial nerve. The ulnar side of the anterior portion is innervated by the ulnar nerve, and the radial side of the anterior portion is innervated by the median nerve. So the extrinsic flexor muscles of the digits there two of them, the flexor digitorum superficialis and the flexor digitorum profundus, and then the thumb has the flexor pulleys longus. So the superficialis and profundus, their 8 tendons go through the carpal tunnel along with the median nerve. All of the extrinsic flexor muscles originate from the medial epicondyle of the humerus and the palmar surfaces of the radius and ulna. So this picture has all of them on there. So the flexor digitorum superficialis, it has 2 heads that split distally. You can palpate the tendon medially to the palmaris longus. It's really easy to find. The tendons in the flexor tendons, particularly in your wrist, are very easy to find. So it originates on the common flexor tendon and a little bit on the coronoid process and the anterior radius. So it inserts on the sides, it splits in 2 and inserts on the sides of the middle phalanx of each of the 4 fingers. The middle phalanx. So it flexes the MCP joints and the PIP joints of the fingers and gets the median nerve. So you can imagine this tendon coming down. First, it splits into 4 tendons and goes through the carpal tunnel. And then each one of those 4 tendons splits into 2 to go to the sides of the middle phalanx of each of the 4 fingers. So it takes care of all the joint flexion except the distal IP joint. And we'll talk about who does that. It's the flexor digitorum profundus. So it runs through the split of the flexor digitorum superficialis to only flex the muscle. It's the only muscle that flexes the dips, the distal IP joints. So the little rhyme that I have to remember this is the superficialis splits in 2 to let the profundus go on through. So, there's our mnemonics again. So the origin, it doesn't go as proximally as the superficialis, and it's deeper. That's the profundus part. It's deep. So its origin is on the anterior ulna and interosseous membrane, and its insertion is on the distal phalanx of digits 2 through 5. So it also splits into 4 tendons, and then those tendons dive through the split in the superficialis to go out to the distal IP joints. So they flex the MCP joints, they flex the PIP joints, and they flex the DIP joints. The lateral half of the digitorum profundus is innervated by the median nerve, and the medial half is innervated by the ulnar nerve, just to make it interesting. So the flexor pulleys longus is the only muscle that flexes the IP joint of the thumb. Its origin is on the anterior radius and the interosseous membrane, so it's lateral to the flexor digitorum profundus, and its insertion is on the distal phalanx of the thumb. So on its way down there to the distal phalanx, It flexes the CMC, the MCP, and the IP joint of the thumb, and it has a line of pull for wrist flexion as well. And it gets the median nerve. So embedded within each of, we talked about the fibrous digital sheath inside of each finger, where all that stuff is crammed in there. Embedded within each one of those, there are pulleys that surround the flexor tendons, providing them with nutrition and lubrication, which is kind of cool. Following a tendon injury, you can get adhesions that develop between the tendon and the adjacent digital sheath, and that's called trigger finger. It's where your finger gets stuck in that flexed position. I've actually had good luck treating people with trigger finger with Graston tools. I like doing hand therapy. It's fun. The clinic I work in now, we have 2 neurological hand specialists who are both OTs, so I never get to do hand therapy. But I used to work in a clinic where we didn't have that, and I got to do a lot of hand therapy. So a lot of times the specialty areas that you get to work in depend on the clinic that you work in. As a PTA, if you're an OT or a PT, you can develop your own specialty, but as a PTA, you have to work with the specialties that are available in your clinic. So if you are interested in a particular specialty, say you're interested in hand therapy, you want to make sure that you choose a clinic that allows you to do that. There is a passive finger flexion action that is called tenodesis. Teno meaning tendon, esis is an action thing. The extrinsic flexors of the digits cross over the anterior side of the wrist, and the wrist position alters the amount of stretch you put on these muscles. So this is sort of an active and passive insufficiency thing. When you stretch a multi-articular muscle at one joint, creates a passive movement as another joint. That's the tenodesis action of the muscle. So if you, in the picture, if you start in the picture on the left and you relax your fingers, don't flex your fingers actively, but just extend your wrist actively, you'll see your fingers will naturally go into a flex position passively. So the wrist extension stretches that. When you use active wrist extension, you're stretching the finger flexors across all those joints, creating passive insufficiency of the finger flexors. And so that creates that functional grasp. There is a video in the module which is really interesting to watch. It's a guy with a cervical spinal injury who talks about how a spinal cord injured person can use that tenodesis action for a functional grip. And he demonstrates it using like a pen and opening a water bottle and that kind of thing. So it's pretty neat. So when you're working with someone with that type of injury, you don't want to overstretch their finger flexors because we want some of that passive tension in order to get that functional grip. So the extrinsic extensors of the finger, the extensor tendons don't attach directly to the phalanges. There is a connective tissue mechanism that's called the extensor mechanism or extensor hood. The proximal end of the extensor mechanism is the dorsal hood, which wraps completely around the MCP joint. So there's a lot of structure at the MCP joints. The extensor mechanism serves as a primary distal attachment for both the extensor muscle tendons and the intrinsic muscles of the fingers. So those extensor muscles don't connect directly to the phalanges. So extensor digitorum, easily palpable on the dorsum of the hand. Those are those tendons you can see. They attach via the extensor expansion to the proximal phalanx of the 4 fingers. The origin is the common extensor tendon. Extensor digitorum attaches to the common extensor tendon at the lateral epicondyle. So that tells you right away it's going to get the radial nerve, right? Posterior side, lateral epicondyle, radial nerve. They all go together. extensor digitorum, its name tells you it extends the fingers, it tells you its action. Its insertion is the base of the extensor mechanism and the base of the proximal phalanx of the four fingers. So it's that finger extension. The extensor indicis, so we have two extensor muscles that are just for extending the index finger and the little finger, which is kind of interesting. Having to do with functional hand motion and fine motor skills. So the extensor indicis also attaches to the extensor expansion. You can differentiate by palpation the extensor digitorum tendon from the extensor indicis tendon. The origin of the muscle is on the posterior distal ulna. Posterior gets the radial nerve and the interosseous membrane. It blends with the index tendon of the extensor digitorum. There is a point in the hand where you can differentiate between the two. So we can try it. I'm feeling mine. Yes, I can differentiate between the two. Okay, and extend your index finger. And I say that the functional use of this is for getting in someone's face, extending their index finger, or for librarians to shush people. But my friends who are librarians would probably object to that. But it extends the index finger. So we have a muscle just for that. Kind of cool, right? We also have a muscle just for extending the little finger, the digiti minimi, extensor digiti minimi. So remember how we said the fourth and fifth finger have more motion for working on grasp? I think that's probably why we have the extensor digiti minimi too, for control of that little finger. So you can think of mini-me, like the guy from Austin Powers, the evil, Dr. Evil, or whatever his name was, where he put his pinky up to his mouth and he had his mini-me. Anyway, that's a terrible mnemonic. But it has a deep, the muscle belly is deep near its origin and it becomes superficial at the wrist. So its origin is actually on the extensor digitorum, on the ulnar side of the belly of the extensor digitorum, which is kind of interesting. It's a muscle that originates on a muscle. The insertion blends with the little finger tendon of the extensor digitorum, and you can palpate the difference between the two. It extends the little finger. It's the mini-me. And it's posterior, it's an extensor, it gets the radial nerve. So the extrinsic extensors of the thumb are the extensor pollicis longus, extensor pollicis brevis, and abductor pollicis longus. The tendons of these muscles make up the anatomical snuff box on the radial side of the wrist. The tendons attach to different regions of the dorsal side of the thumb, and they might have other actions, but their primary actions are in their names, extensor and abductor. So I hope in lab you found your anatomical snuff box and you palpated those tendons. I don't necessarily need you to know all the origins and insertions of these, but knowing that they make up the anatomical snuff box is okay with me. The extensor pollicis longus, its origin is on the posterior ulna and interosseous membrane, and it goes to the base of the distal phalanx of the thumb, extends the CMC, MCP, and IP joints of the thumb, and its posterior gets the radial nerve. It's an extensor. Extensor pollicis brevis, also an extensor. Posterior radius on the interosseous membrane and the base of the proximal phalanx of the thumb, extends the CMC and the MCP joints of the thumb, but not the distal. So the extensor pollicis longus goes longer and it gets the IP joint of the thumb. The brevis is shorter and it doesn't get the IP joint of the thumb, but they both get the radial nerve. So in this picture you can see those tendons running up the radial side of the thumb and forming the anatomical snuff box. So that's pretty cool. The abductor pollicis longus, it abducts the whole thumb, even though it inserts on the metacarpal. So it does it by dragging it along, basically dragging the rest of the thumb along. Because abduction aren't in the same plane as the IP and MCP joint, I think that's why we can say it abducts the whole thumb. So its origin is on the posterior radius the posterior ulna and the interosseous membrane. It's posterior. It's an extensor. It gets the radial nerve. This is a pattern. And it inserts on the base of the first metacarpal. So it does abduction and extension of the CMC joint, basically. The intrinsic muscles of the hand, what I want you to know about these guys is their groups. So the muscles of the thenar eminence, all three muscles insert on the transverse carpal ligament and on adjacent carpal bones. The thenar eminence is the muscle belly right proximal to your thumb. It includes the abductor pollicis brevis, flexor pollicis brevis, and opponens pollicis. Their names tell you what they do. Abductor pollicis brevis abducts the thumb. Flexor pollicis brevis flexes the thumb. Opponens pollicis does the combined motion to do opposition. I just want you to know that they are part of the thenar eminence. Those are the members of the thenar eminence is what I want you to know. Where they live and what they do. Not necessarily their exact origins and insertions. The muscles of the hypothenar eminence are on the ulnar side of the hand, just proximal to the digiti minimi, the little finger. So it's the flexor digiti minimi, abductor digiti minimi, and opponens digiti minimi. Same flexor, abductor, and opponens as the thenar eminence, except it's digiti minimi instead of pollicis. So I want you to know the group and what they do. Your hypothenar eminence is super useful in manual therapy for not wearing out your IP joints of your hands. I use that hypothenar eminence every single day. So a lot of times I'm digging my hypothenar eminence and my pisiform into somebody's muscles to do myofascial release. The adductor pollicis and the lumbricals and interossei are intrinsic muscles of the fingers and thumb. The adductor pollicis is basically the thing that fills up the web between your index finger and your thumb. And not surprisingly from its name, it adducts the thumb. The lumbricals and the interossei are intrinsic muscles of the fingers. And I don't necessarily need you to know their exact insertions and origins, but their function, you should know their function. So the lumbricals are 4 tiny little muscles originating from the tendons of the flexor digitorum profundus. They don't attach distally to bone, but they attach to lateral bands of the extensor mechanism. So these muscles, this is what I want you to know. They flex the MCP joints and extend the pips and the dips. So they give you that hand position, which is referred to as a lumbrical position. It's a position that you use when you're handing somebody a plate or making a shadow puppet on the wall, or handing someone a book, or holding a tray. That is a lumbrical position. We also use the lumbrical position to hold on to somebody when we're doing manual muscle testing so we don't dig our fingers into them. So by doing the MCP flexion for the grip and the PIP and DIP extension, we avoid digging our fingers into somebody's flesh while we're doing manual muscle testing. So if I asked you, so that position of the lumbricals that's pictured in this diagram is called the tabletop position. So if I asked you which muscles perform the tabletop position, you would know that it's the lumbricals. And you would know that the tabletop position involves the flexion of MCP joints and the extension of PIP and DIP joints. Okay, that's what I want you to know about the lumbricals. The interossei are named according to their location between the metacarpal bones. There are palmar interossei and dorsal interossei. What these guys do is they ab and adduct the fingers. So all 8 of them are innervated by the ulnar nerve. So interossei are innervated by the ulnar nerve. The dorsal interossei abduct the MCP joint away from an imaginary reference line through the middle finger. So the way we remember the dorsal interossei abduct is DAB, dorsal abduct. So they take the fingers away from the middle finger. The palmar interossei adduct the fingers toward the middle digit. PAD, palmar adduct. Okay, that's dab and pad. That's your mnemonic for the interossei. So those are the fingers that those are the muscles that take the fingers away from the middle finger and take them back towards the middle finger. So wrist extensors during finger flexion. We talked a little bit about making a fist and how making a strong fist requires equally strong synergistic activation from wrist extensor muscles. There was that picture in the book with the dynamometer. Wrist extensor activity can be verified by palpating the dorsum of the forearm while making a fist. So do it right now. Make a fist and you can feel the extensor carpi radialis brevis and extensor carpi radialis longus on the dorsum of your forearm firm up. You can feel those muscles working. If your wrist extensors are paralyzed, attempts at making a fist result in a posture of wrist and finger flexion, which is a weak and ineffective action. So a wrist extension splint can give you a much better grip if you don't have the wrist extensor muscles to do it. Common deformities of the hand, and you'll talk more about this in your upper extremity orthopedics class, but deformities of the hand are often caused by diseases or trauma that disrupt the balance of forces around the joints. So there are 3 types of hand deformities that are typical in hands with severe rheumatoid arthritis. One of them is ulnar drift, and that's where the phalanges sort of start to drift towards the ulnar side. It's a deformation of the MCP joints. The swan neck deformity is you get hyperextension of the pip and flexion of the dip. So you can see that in the picture there. And then a boutonniere deformity, you get flexion of the pip and hyperextension of the dip. So I just, these kind of things tend to show up on board exams. So you will review it definitely in your upper extremity orthopedics class a year and a half from now. But it's just something like plant the seed and be aware of it. I don't think I have any questions about common deformities on the exam, but it's something nice to stash away in your brain for later use. So the joints of the hand are organized into 3 sets of articulations: carpometacarpal, metacarpophalangeal, and interphalangeal. The MCP joints form the base of each digit. They're your knuckles. The IP joints flexion extend only. Other potential planes of motions are blocked by bony fit of joint and periarticular connective tissues. Simultaneous extension of all 3 joints of the fingers requires coordinated interplay among muscles. So it's pretty neat that we have those fine motor skills that we can do that.